Okay. Okay, so this is so I'm trying to introduce what's happening with the Manta Institute. Okay, so go here. So the okay, and uh, okay, so what I'm trying to do is this. I will I have the vision. I want to get somebody a field medalist from Sri Lanka. So that's vision. So once you have a vision, it's like you can guide your actions according to that. Okay, so the mission. So you'll send out 50 students for PhD programs. But yeah, uh, good, good PhD programs. Okay, and getting a field medalist, very unpredictable thing. You have to have like a lot of other stuff too for that to happen. But you start with this. Okay, once you send out 50, then somebody will come out. But if you're not sending good, well prepared students, then that's not going to happen. Okay, and so that's the mission. And what I'm doing is I'm doing this. Okay, and I take students for in here. Students take students for this foundations course. Like so that's the starting post for uh, uh, like just writing the proof. So this is suitable for somebody who's finished A level and then starting actual rigorous mathematics. Okay, so and in here you will learn like how to write a proof, mathematical proof. Okay, and then okay, so this one has two components. The first one is basic, like the foundations of writing proofs and logic and set theory. And there is advanced part where you kind of dive very deep into the foundations. And I have started this, and then there is actually there's one introductory video about this, which is kind of long, like a half an hour video. And okay, and then there are these courses. So this one is the analysis one course. And so we have the analysis one and analysis two. The analysis one would cover, we are planning to go through, and we are going through Terence Tao's book, Analysis One. And it is currently taught by Dr. Ram Singh. And there are lectures and online lectures. And the key thing is when you submit homeworks, we will grade your homeworks. Okay, and the same with the foundations course. So basically, you cannot learn how to write a proof if nobody's grading your homework. Okay, so that's something very very serious about. Okay, so you submit the homework, so we'll correct your homework and then give it back to you. Okay, and then we have the linear algebra course. This is something we like actually like even like everybody in like even in engineering need this thing. Okay, and we will do the course, but more importantly, we will do the full course. Okay, so let me go through this thing a little bit. So these are the courses going back in uh, back in, uh, so I'll give you a little bit more detail about the first the first row. These are like the semester one courses. Uh, okay, I'll tell you a little bit more about these things. Okay, so let's go here. So this is the beginning course. That's the foundations of mathematics. We'll go through logics and set theory and number systems. Okay, and then you have the first semester courses. In here you have the analysis course, and then you have linear algebra course, and so the analysis course is here. We'll cover uh, chapters 1 to 13 of the Taos book, and then we'll have analysis 2 course that will cover the second book. And you have linear algebra course. This is interesting. So what you're going to do, so this is the linear algebra, I would call it the full course. Okay, and we'll cover the whole book, linear algebra done right from beginning to end and all the chapters. And even if you go to a like math special degree like anywhere in the country, you'll not cover the full book. Okay, so you're probably not going to do the last parts of it. Okay, but we will do it, and uh, we'll do it. And again, this course we're doing it in a slightly um, different format, in the sense that we are not going to do the lectures by ourselves, because this textbook and the author Alexei, he has like he's basically going through the textbook and with some lecture videos. But I have put up all the homework problems for this course. And if you join the course, and you can start submitting the homework. You submit the homework again, like we will grade them and give it to you. Okay? So that's a linear algebra course, and we'll go through the full course. Okay, and the homeworks are already up in you can start submitting homeworks. And this is the other one. This is abstract algebra. This is actually going to be taught by, I mean, she's teaching this one right now. Have a couple, like 3 lectures already at this point. We are going to go through the Fraley's book. It's the first course in abstract algebra. And again, like this is important. And I think this material is only, if you're in Sri Lanka, you only learn it from when you get to math special degree, or in general degree in third year. But this is important, and in actually in UCSD, University of California, San Diego, there are the abstract algebra course that has more than 200 students. Okay, so somebody is thinking this is valuable, and somebody is like learning it. Okay, and it's like it's unheard of, like having that many students for a theoretical course like this. But yeah, and this is needed for the all the follow-up courses. And we have the statistics one course. This one is actually we have Professor Sarath Banhekar teaching this one. He's from University of Sri Jayawardhanpura, and he's teaching it in person, but we have the video lectures, and we are covering the statistics one. We're covering this book, Statistics by David Friedman, and this book is very special. It has no math, like it's so you don't need the foundations to go through this course. Okay, but it doesn't have like it's not like full of formulas and everything, and there's no plugging into formulas, that sort of stuff, but it'll teach you all the concepts of statistics and really well. Not all, like most of the concepts. Okay, uh, and then you have this course. This is happening right now too. This is functional analysis, and this one is actually semester 3 course. If you go here, uh, this one is advanced, and we're doing this thing because uh, some of the students needs it to take more advanced courses. And I mean, it is a third semester course for us, but uh, yeah, but it is a foundational course because you're gonna have like a lot of things depend on it. You have the partial differential equations, quantum mechanics, and all that is going to be dependent on the functional analysis course. Okay, so these are the things that are happening right now. So we go back here. So I have explained this first layer of things, and there is a geometry and physics course that is still designing it. Uh, I was getting stuck. Okay, so we have the plan for the geometry and physics course, and this is going to be like a very beautiful course. We will actually uh, start with the high school geometry, and we have this question. Okay, so like the main one of the main things that you can do. So geometry, like think about this. Okay, so in high school geometry, uh, so I mean we drew pictures, but when we do proofs, we're like kind of actually working with axioms. Okay, we have the picture, but if you remember, like we're not actually using the picture for the proof. Okay, so what we are sort of actually doing is we are actually doing things based on the axioms. Right, so we'll do that first. So we'll define what a geometry is, and then we actually the definition would come from um, uh, some sort of axioms on a they call a lattice. So we'll define what geometry is, and you'll connect the high school geometry to that axiomatic one, and uh, then you have coordinate geometry, kandang geometry. Right? In coordinate geometry, you write the lines and equations and triangles, all that in hyperplanes, planes in using the coordinates, using like R, like the real numbers, and you have three axes, right? And so it looks like the that axioms we had, like those pictures or like the axioms that we had in high school, those got somehow embedded into the coordinates, right? So there is a theorem called fundamental theorem of coordinate geometry. Uh, so that one is going to be we'll prove that one. So that will tell you something like if you have a geometry with certain axioms, you can actually find the real line itself. In the sense that the like real line would be an example of a division algebra. It's like a field, but field in the sense that you can like add and multiply, and then you can divide by non-zero things, and you'll define what the algebraic structure is. I mean, that is the topic for the abstract algebra 1 course. But you'll connect the coordinate geometry with the high school picture geometry. Okay. So that's one thing we do in the geometry and physics course. Then the physics part comes in. We will define what a mechanical system is. Okay, so we'll define what a mechanical system is, and it is a definition that's based on like again something called a logic or some sort of lattice, and you'll go through it, and it is totally accessible, and uh, and then with that we will define all the core concepts in mechanics, like what is the observable and what is the state and what is the spectrum and all that. How do you talk about dynamics? And we'll do all that in that definition of the mechanical system, which is in the mechanical system you'd have a lattice called a logic, and that is like the high school geometry is going to be one example of such a lattice. Okay, so that's why. So you have the geometry and physics, they are going to be like very, very connected from the very, very foundational levels. Okay, and then you'll be able to define what a um, you'll be able to have special properties of the lattice that differentiate us from the that breaks into two types of mechanics, classical and quantum. And so we will be able to like when you learn quantum mechanics, you cannot do it without functional analysis. You cannot even define like the basic things like what is a state, what's a observable, how do you do dynamics without function. That's but in this way you can do it. And this is actually from the same guy who did foundations for quantum mechanics. It's von Neumann. Von Neumann like first did the kind of foundations using uh, quantum mechanics, using functional analysis. But then later on, he said like, no, there is a better one. So let's follow that. And but nobody like kind of got into that much. But we are going to do it. So that these lattice-based definitions, those are foundations of quantum mechanics. But we'll have that as the first course. Okay, we are not going to go into the quantum side, but we'll do the classical side. And then we'll end the course by, so there is a theorem like for the whatever the lattice we get, it's going to be in the classical case, that's going to be called a Boolean algebra, Boolean lattice. And then there is a theorem that brings that Boolean lattice that tells if such a lattice is actually equivalent to special type of topological space, and so you'll recover the what do you call states, not the states, sorry, the configuration space as a topological space. So we'll go back from the lattice thing to the usual picture of dynamics, where you have some state space and then you have flow in there to describe the dynamics. And then finally, my plan is to we'll do finally I'll define what a differential equation is, and then we'll prove the basic existence and uniqueness theorem for differential equations. So at the very last part, that's going to require some analysis. But hopefully with the analysis one course, that part would be covered. Okay, so this geometry and physics course actually depends on foundations, but the very last section would depend on analysis one. And this would be like a really, 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 really nice course. And so that's the first layer of things. And then you have uh, a second layer. So we'll have analysis two, and then I'm going to teach this one, the probability theory. Uh, this is going to be this is the this is going to be rigorous probability theory, meaning probability theory would be defined using measure theory. So you'll have to call a probability space. That's going to be a measure space with yeah, measure one. So I will go through this, and this would be your first introduction to measure theory. I mean, we'll construct the uniform measure. That would be exactly the same as constructing the Lebesgue measure. So you'll keep in mind that you haven't seen measure theory. We'll develop it, and then I'll go into proving things like law of large numbers and things like that. And then if you have this, now you know what a probabilities, you know, like probability theory correctly. And so there is a statistics course, follow-up course. This one will run in parallel with the probability theory course, and this statistics 2 course would have we are planning to do cover a book like this textbook called All of Statistics, and so that one you can kind of do it without the knowledge of uh, probability theory, because you can define the random variables in a like non-rigorous way. Random variable is same as a measurable function. So you can define it that way, and but while you're doing it, you learn the rigorous stuff from the other course. So these two can like run parallelly, and once you have that, then there's another course here. This is a very serious machine learning course, uh, and this would be like this would be understanding machine learning from theory to algorithms. There is a textbook under that name, and there is lectures, and this would be like you'll have theorems in machine learning. Okay, this is like very, very foundation. We are not like trying to, this is not the engineering part of things. We will have, I mean, one of the theorems we will prove in here is called the fundamental theorem of machine learning, the pack learnability theorem. Those are very, very good theorems, but at the same time, you need like analysis to understand it. Okay, even write down the statement. So for example, like that theorem itself has like so many quantifiers, way more than the definition of like continuity differentiability. Okay, so I mean we are interested in the theoretical foundations, and then you have this course, topology. We're planning to go through the Moncrief course, a Moncrief textbook. This would this would you'll be able to do a little bit faster because you have analysis 2 here. That would cover metric spaces. So first part of it would be kind of helped by analysis 2. But you'll go further. I mean, there is a, with this, you will do we'll cover a lot of stuff. I think yeah, I mean, back in the days in Colombo, you had like good like solid courses, but right now I think they have a 3 series course on topology, and probably we'll cover this one way more content in here. So yeah, I mean the people who fail qualifying exams and so on, they haven't done math and they have written essays to get math PhDs. And people like that teach, that happens. It's like spread it out like that. Yeah, series is like Kumbiyai, Ganga, this giant course. It's it's big for him, but it's not that difficult. Yeah, it is a big thing for somebody who failed stuff. But anyway, the Colombo used to be good back in the days. But anyway, so I'm actually from University of Colombo. And then you have next course, abstract algebra. Uh, we'll go through the Damit and Foot, and we'll have another one, classical number theory. Uh, so this would be a little bit nice and can do a little bit more advanced stuff because you have the support from abstract algebra. Um, and here is the functional analysis course. This one is happening right now. Oh, I forgot this one. The geometry and physics too. In here, we will go through manifolds, and we have Dr. Guy Energizing her. It's from University of Peradeniya. He's planning to teach this course. And actually, he went to the same place as this guy, the guy who's teaching topology. And but he passed the qualifying, and then he got a PhD from that place. And this guy failed qualifying in that place. That means he has to take qualifying exam 4 times and fail all 4 times. And then he went to a different university and failed again 4 times. And yeah, but the guy who's teaching this course, he has passed qualifying, and of course he has PhD from the university. And yeah, he's good and he's doing research. Yeah, that's the guy who's going to teach you, teaching here. And the functional, and then you have this course. This is Roding's Real and Complex Analysis, the Roding's second book. And Dr. Ram Singh agreed to teach this course, the first part of it, the analysis part, the real analysis part. And in here, we're doing the analysis in introducing measure theory, but in a different way, use something called phase representation theorem to construct the measure. So it's like basically in when you learn it for the first time, so which I will do in probability theory. So we're constructing the measure. You start from the measure theory and you get to the integral. Right, and in here, the way you start is you start with the properties of the integral and you recover the measure. Okay, and there is a follow-up course in here. That's the complex analysis part of the same book, and I'll teach that part. And then we have this guy, mechanics course. This would be like we know the knowledge of manifolds, and then we have ODs and like what a mechanical system is. So in this mechanics course, we will go through like Hamiltonian dynamics and like the good stuff. Okay, um, and then we have geometry and physics 3. In here, we'll try to do we'll try to get to the setup of general relativity. And so this would be like more geometry. We'll have bundles and connections and so on and so on. We are trying to actually do Catan geometry in here and give the general relativity side of things. Okay. And I talked about this course, Understanding Machine Learning. And then, so what's happening in the next level? I talked about this one. And in here, the commutative algebra and algebraic geometry. This one would be a follow-up to the abstract algebra. And then we have graduate PDEs. So the graduate PDEs, you cannot do it without functional. Okay, so you do that in here. And also in here, I mean, we can do a little bit of calculus variation too. That would be that would allow us to define Lagrangian dynamics. So we'll do that too. Because the classical mechanism has two parts, the Hamiltonian one and the Lagrangian one. Lagrangian one, you need more functional. And then this is the last part in geometry physics thing. So geometry and physics, the final thing, you have mechanical system, and in the other side you have the observers. So the final theories would look like how the mechanical systems change with the observer. So that's the topic of field theory, or like quantum field theory or classical field theory. We'll go into that, but we need the two components. The first, this course, you need this course to understand the kind of the what is generated by the observers, like how do you talk about different observers, and that side you'll bring it up to a category in there. And in the other side you have the mechanical systems. So you have the classical mechanical systems, and the functional analysis would allow us to define quantum mechanical systems. And then in this course you have the kind of the how the how the mechanics, how the dynamics is changing with respect to the observer. And you'll get the formulations and you'll do like simpler cases. But in here you have done it like in the kind of very, very, very solid way. Because for example, we are starting with this definition here. Okay. And talked about this one. This would be like a really good complex analysis course. I forgot to tell you, like in here, in analysis 2, we are going to throw in the basic complex analysis into that analysis 2. So, and yeah, because we have the help from topology 1 to deal with the metric spaces stuff. And then we have topics in geometry, and you can do like much more stuff. You can do harmonic analysis. And yeah, I mean, this list is not complete. But like this is the plan. The core thing is the first line. Just get the first line, and especially if you're somebody who finished A level, do this one, the first one, foundations course, and then get the first layer done. Okay, and then you'd be at you have like solid foundation to do mathematics if you want, but also to engineering. This would be like should be like really good foundations for like you can do engineering in anywhere in the world. Like for example, in actually the textbooks we use for analysis 1, there is the we're using Tao's book. The previous book was Roding's book, and then there is another book we might use it next year, which is a book by Apostle. So the Roding's book and Apostle book, those are like first year textbooks in MIT and Caltech. Those were written for those courses. And in there, it's not just the math students. For example, like chemistry undergraduates or even biology undergraduates take those courses. Okay, so if you have this foundation, you can go this is going to be good, and you'll be at the same level as any university in the world. Okay, and especially if you, this is also something like, if you're planning to apply and go abroad, uh, take these courses, because if you take these courses, and we can write you a letter, and like, you have already done the things that they're going to do in those places. Okay, so uh yeah, so this is the set of courses that I'm planning to teach, but I'm not teaching all of them at once. And there is another one that I'm doing. I'm sending people to here. This is the Math in Moscow. So the idea is, like, there are courses that we cannot teach inside Sri Lanka, and they are like graduate courses, and I mean, the Sri Lanka doesn't have experts in like every field, and actually the universities are full of people who uh, you know publish in like just bad journals like Citrapatra, just publish articles in Citrapatra, and then they can go up, and they don't know, they haven't proved the theorem in their lives. If you look at who proved the theorem, that's going to be very, very, very few people. Anyway, so when I don't, like, I use this thing I have sent. So this is the current semester. I can show you the current students here. Uh, so these are the students that are already there. So you have people from Oxford, two kids from Oxford, Ohio State, University of Toronto, University of Colombo, and St. Petersburg, University of Colombo, University of Colombo. I should say like Manta Institute. And like, there's a lot of kids I sent there. And then these kids I have mentored since they were in first year, second year. I was in Sri Lanka, and then yeah. But there's 13 of them in here, uh, from Colombo and so on and so on. And one of the reasons for this meeting is I want to create a new batch for the next semester of courses. Okay. And so that's, I mean, I call this thing a preparation course, and it is the preparation for this Math in Moscow. Okay. And these are the courses that's offered in this semester, January semester. And so the abstract algebra one, that one, we don't need to go into this program to learn. Okay, so the abstract algebra one course, the content we can actually cover in here, in this abstract algebra one course. Okay, this one taught by Dr. Almeida, and it's happening now. So nobody's going for this course. Okay, and advanced linear algebra, the same thing. You'll be able to cover this content at the end of the linear algebra course. Okay, so this one would have that. Okay, but this one, ordinary differential equations, this is a really fun course. Okay, and it's a really fun course. They're actually following the book by Arnold. Okay, yeah, this guy. This guy's a legend. Okay, and he has a beautiful book, and they're gonna go through it. Okay, and I want to find students for this course. Okay, and to take this course, you need uh, you need uh, you need analysis one. Okay, you need analysis one and linear algebra, right? And so these two courses are currently going on. If you jump into these courses, especially, I mean, this course is not. I'm not allowing like third years or fourth years. So I want somebody in high school or first year or second year. Ideally first
I
year,
am
no?
second.
Huh?
I'm second year, sir.
Yeah, your second year. But you have taken analysis, right?
Yes, sir.
You have taken linear algebra too.
No, sir, just linear algebra.
How about analysis one?
Yes, sir. I've taken foundations one and two, analysis one, linear algebra, and abstract algebra.
Are you taking those things right now in through
Yeah,
Manta, or are you doing it with the Japura?
through Manta, sir.
Okay,
I
okay.
have,
So in that case, you apply for the ODE course. Okay,
pardon?
here is the trick. Here is the catch. So you have to learn these things very well, and I'll grade your homework and everything. But you learn it well, and to get accepted to the course, they will have a interview. Okay, so you can have like giant CV, but you will not survive 10-minute conversation with the math professor if you don't know math. Okay, good.
Yes, sir.
Yeah, I mean a lot of those Sitrapatra people, they won't be able to stand the interview with math. Okay. Uh, Now, so you'd be a candidate for that course. Okay. Now let's go back here. Let me uh, go here. And then you have advanced algebra course. This one is also this one is something I ask students to apply, but you need uh, ideally this is good for somebody who has done abstract algebra 1 and even abstract algebra 2. Probably 1 is enough. So abstract algebra 1, you have seen group theory, ring theory, field theory, like the basic layer, but you haven't seen the Galois theory. For example, you have so and there are a few students I asked them to do the abstract algebra 1 course really well, and then you try to apply for the other one. I think there is a kid, Sarangi, Sarangi from Japura. Probably you know that she's a demonstrator, I think now. And
Oh, yes, sir. I know.
I asked her to apply for this one. And the analysis on manifold, that's a course we can do like inside the country. So nobody's gonna. I'm not gonna send people for this one. So analysis on manifold course would be the one that this course Dr. Gayan is teaching. He's the one who passed qualifying that this guy failed. Okay, so uh, he's a geometry. He's a good guy. He actually does research and yeah, he's actually a treasure in the sense that there aren't many geometry people inside the country. And I mean, I'm an analyst, and what I can do in analysis, there's so many people who can do it in the country. And I mean, the reason for that is in University of Colombo, we had uh, Abhay Singh sir. So he taught analysis, and there is a huge, huge, huge amount of analysts under him, grew up under him, including Dr. Ram Singh, and everybody in the med department, Kalampa med department, was a student of him. And I think I was one of the from the last generation. So Abhay Singh sir taught me, but not the next batch. That is the batch of Kaushika de Silva. Anyway, so going back into here, so nobody's uh, going to do analysis on manifolds because we can get Guyana to teach it. And then you have knot theory, and I'm sending some people for this. And another interesting thing is uh, Almeida, Dr. Anna Almeida. She's the person who's teaching abstract algebra course. Her area is knot theory. This is like pretty cool stuff. So she has a student Pumi. She's gonna go to that. She's gonna apply to that course. But if you are from first year and if you want to go into like if you do basic algebra, abstract algebra course together with first parts of Moncrief's textbook, topology book, which I'm not offering right now. So if you go through it by yourself or you talk to me, and then you can take this course. But you have to have the you have to finish the analysis, linear algebra, abstract algebra, and tiny bit of topology. Okay, this part. So there is one student who's I'm planning to send, uh, but not many. Okay, and then let me go through these courses. And then you have Introduction to Commutative Algebra and Homological Algebra. This one is very advanced, and I have a fourth year student, Vinuga. He will take this course, and but this is open to somebody from like third year or fourth year, and who has done abstract algebra, who has done abstract algebra kind of 2 times. Should know the abstract algebra 1 and also abstract algebra 2. So you have covered abstract algebra from Damit and Foot, for example. Then you can go to that one. I think there is I have one student that I'm planning to send to that. Yeah, somebody from Pera, I think Peradini. Now, yeah, the next course is Riemann surfaces. This is a good one. Uh, uh, so you need complex analysis for this, and there are some kids from Moroto Isita is taking the complex analysis course right now, and then he will be able to take this one. Okay, and so these are the courses that are happening right now. And so let me go back and show you the full list of courses. But like they might offer the other courses next semester. I mean this course I wanted them to offer, but they didn't offer it. This is the graduate PD course. I might try to planning to get this thing done next semester, which is from here, because I have the functional analysis course happening right now. And the reason for that is I want this course, graduate PD course, next semester. If you want to learn like partial differential equations like theoretical way properly, get on the functional analysis course. I'll try to get this thing done next semester, like January. And there is actually a guy in University of Jaffna, Myron. He has done graduate PDE. I mean, his area is PDE. And also Dr. Panis from Japura, he can easily teach this thing. Okay, so there are people who can do this thing. And now, hope this is okay, but because I'm going through the kind of the overall plan, and there are students who come into the program and they get lost, and I will have this video and I'll just upload it. Okay, and uh, let me go back here. Okay, so let me go through these ones again. So you had abstract. So this is the full set of courses, and you want to think of this set of courses as sitting around this set of courses. Okay, so we have these ones, and there's outside of these things, you can put some of the Math in Moscow courses. Okay, good, and I'll tell you about those things. So the reason for Math in Moscow is you get exposure to graduate topics that we don't teach in Sri Lanka. And the other reason is uh, you can probably get letters of recommendation, and it is a good way to get letters because you get compared with uh, I mean they have taught uh, like they have interacted with kids from Oxford and everywhere. So uh, yeah, so this is a so in in Sri Lanka we have a yeah. So I mean, you get connected to a good community and you get to learn good math, and then you can get letters of recommendations. And I want to be able to the students to like uh, get a letter if they know math, and so somehow like that's I know that in Colombo, for example, uh, they think that there have been cases that uh, give me a second. This yeah. So yeah, it's yeah. There's letters of recommendations. Uh, Sometimes it's hard to get those things from for some students, even though they're like very good. So that this thing solves that problem too. Anyway, so let's go back and I'll show you the how these courses sits around the courses that Manta offers. Okay, so you have the abstract algebra one. We are not taking it. At advanced linear algebra, we are not taking it. Analysis one, analysis two, we are not doing this. Foundations of analysis. This is the foundations of mathematics course. Non-Euclidean geometry. I will cover part of these things in geometry and physics one course. Ordinary differential equations. You go there and learn it. Okay, and topology one. This is a good course too. Actually, a lot of kids already take this course, and this is basically like topology, but also does like a fundamental group homotopy theory. Okay, so there are kids taking this, and I'm very happy to send people to this one. But they're not offering it next semester. Okay, advanced algebra. I want you guys to go there and learn it, and I want Algebraic geometry course, go there and learn it. Algebraic number theory, you go there and learn it. And there are people who are learning it right now. Dilmi, Dilmi or Dilmini, Dilmi or Dilmini, Dilmi. Where is she? Oh, here. Dilmini. Dilmini is taking that course from Math in Moscow now. Uh, you go learn it from there. Analysis of manifolds, don't have to learn it from there. Basic representation theory, go there and learn it. And there's actually a lot of kids learning this right now. You have Sukiti, you have Asiri, Sukiti from fourth year, Tharid from fourth year, Colombo, and you have Asiri, they're learning it. Complex analysis, there's two kids, they're both from Moroto Engineering, Isit and Manit. They are learning it, but uh, somehow if you're in a math program, we'll teach it inside Manta. Differential geometry, this one will teach, Guyana will teach it. Dynamical systems, go take this one if when they offer it. They are not offering it next semester. Not theory, they are offering it next semester. And this one too, they are not offering it this semester, but this is something good to take from there. Okay. And we have this one. This is, yeah, go and take this one. This is actually the area of Dr. Jayampati Ratnayaka. And I couldn't get him to teach for Manta. I just did everything. I didn't beg for him, but I couldn't get him to teach. Uh, he's Asai Baye. So to teach, but he's afraid for something. But this is his area. We go to Math in Moscow and learn it, but once he build up courage, we will teach it in Manta. This one I'm teaching, but it's also good to learn it from there. This one, if they offer it, go take it. This one again, like they're offering it, and I'm trying to send some people there. But this is like kind of advanced. So I think you'll see you see the plan, you have this. And you have bunch of courses that sits around this curriculum. Yeah, that's a plan, and I really encourage people who have taken who have just done A levels to join Menta and go through this first layer of courses. And it's not going to take much time. Probably you can finish it before uh, not before the results comes. Yeah, I mean you're wasting 1 year. Just do this thing and yeah, and also people in first year. And I mean the thing is like uh, I believe that I can teach. Uh, I actually truly believe that I can teach mathematics to the, the, the all the talented kids in Sri Lanka. So I think it's doable, and I'll do it. And so the university system does it, and I will teach it to much better and much better. And then yeah, I'll protect them from things too. So the Manta Institute, you have the protect, you prove, teach this stuff, and then you connect them to the international community, right? And then protect. So the connect part is like I mean, the first thing you do when you apply for the program, you learn who proved the theorem. That's the point in uh, it's like the exercise zero. You learn about it, and then you know that what's the right people to get connected with. if you want to do pure math, or like if you want to do like advanced math, or like do math, it is about theorems. Yeah, so you have those things, and also here is one more thing that's gonna happen. Uh, Let me tell you one more thing, and then so the with the mission, this is my mission. So you have so this 50 will take 50 out for PhD programs, and I want 200 kids for this, for preparation course. Okay, so that's the first layer, foundations and the first layer. And out of this 200, you'll have like, people who go into engineering, machine learning, all that, but they have that foundation. And I'll send 50 to here. And this layer, this is, I want 1,000 kids from, I mean, the 1,000 is roughly the amount that uh, coming out from scholarships exam, grade 5 exam. So right now there are 6,000 kids in O level, grade 6 to 11. I want to teach them geometry, high school geometry, and then I'll add more stuff. And that thing is going to happen next January. I'll go through the classic this textbook called Navini Jamiti by Dural. I'll go through it. I have Mr. Sarat Kumara. He was the head of the department from Japura, previous head. So he's agreed to teach it. We'll run a kind of pilot program and we'll gather a bunch of kids and teach this thing and see how it goes. And then starting from January, we'll teach it to we'll teach it in hostel. The hostel is where all the kids are, good kids are, and we'll go to hostels and we'll teach it, and then you broadcast it to all the kids in the hostels, and the other ones can join too. But we'll make sure that that this 1,000 who are mainly in hostels, we make sure that they get to stay in touch with the uh, mathematics, because they're the I mean like the high IQ kids, and I want to teach them, and if I keep them engaged from grade 6, and they can, when they come to O levels, before O levels, they can take the those preparation course that we went through. So that's a mission, and yeah, I want to do it, and I will do it. I can do it, and doesn't take much money. I mean, it takes money, but it's doable. It's doable. Uh, yeah. Uh, so and this is all free for students, and students means like I don't take money from parents either. So right now I'm doing it by myself, but I'm planning to get more funding in semester or two. So okay, so I think this is a good I think this is a good introduction for the courses, and thank you for coming. But let me stop the uh, before stopping the recording. Do you have any questions? Do you guys have any questions?
Yes, sir.
Yes, listen.
So I am doing my university course parallel to this Manta
Uh-huh.
course, right?
Yeah,
So would this be like too much if I like take every course that in the semester, or should I? What would you recommend?
I think you take all these courses, and uh, these things would help with the other ones. And I mean, back in the days, I made a shadow syllabus. in the sense that let's say you're taking I don't know, group theory from I know who you take group theory from, but if you're taking it from him, uh, like I'll suggest you follow this book. So I used to have like shadow syllabus for the kids. You get to like learn it properly to the level you want to be approved to prove a theorem. So the so I used that method earlier with with my kids. I had like Colombo syllabus and all that, and I tell like, okay, when you're learning, when you're taking this course in university, instead of just doing whatever they're doing, and you do this thing and then you're done. Uh, so that's one way of doing it. But I think now for somebody like you just uh, we had these inquiries, and I will tell you that it looks blunt, but I'll tell you that if you get overwhelmed by those courses that happen in universities, then you're not ready for this. You should be able to manage that time and do this. I know this is like these courses. It's gonna take a lot of time and effort. But I mean, this is something I used to do in I and like everybody to this day, applied courses in, for example, University of Colombo. So you don't go to lectures for those things, and they have some sort of vacation where there's no like exam month or something, and you just take the notes and you read it, and then you like do a copy session or something. You teach them, you teach the other kids, and then you're done with that course. Okay, so do something like that. And I think if you do these courses, then you can do the same thing with those pure math courses, because you have the mathematical maturity and you'll be able to do it. Okay. And yeah, again, like if you're getting too overwhelmed by those courses, then then you're not the right person for this. Okay, listen.
Yes, sir.
Okay, okay, okay. Uh, but you will get overwhelmed by these courses. Okay, you'll have like huge amount of workload. For example, like in linear algebra and all these things, you'll submit homework and you'll be like a full-time student. Okay, so there are like people who started these uh, these courses, like the preparation courses now, and there are a couple that in the program, and they're not in universities yet, but yeah, in a week or two, they kind of uh, they left the home and they kind of find a boarding place in Nogegoda, and they are like, this is the only thing they do. Okay,
Yes,
so
sir.
and I mean, I used to have the really tough deadline for homework, and the exams would be like take home sort of thing. So you manage your time, and let me know if you have I mean, I have somebody, Isita, would organize extend the homeworks if you need. But yeah, manage your time, and you'll have full workload from here. And yeah, those courses, you'll have the mathematical maturity to do the even the pure courses the way we do applied courses. Okay,
Yes, sir. I will.
okay. Any other questions? I mean, the truth is, with with those, even in math special, I like most of the people in uh, physical sciences, they do another degree. When I was in when I went to Japura, and then I had math special kids, and I asked them like, okay, so what's going on? And as it turns out, there are like kids in math special, and they're doing like, I don't know, like what do you call it? IT degrees. And so the point is like they manage their this thing with IT degree. And that's it's crazy. Crazy in the sense that they're not like fully committed to this. They do IT degree on the side. And I mean, it tells something about the value of the degree too. So the students are not stupid. They know that, you can't get anywhere by doing this thing. And so I think from Japura, if you look at the degrees, if you look at the alumni, uh, when I was there, I think they haven't produced somebody who proved the theorem in like 15 years. Okay. So, I mean, that changed now. Now we have, I was there, and, and, and this Jayanpati and Kaushik. So there are kids going into proving theorems, and there is a guy, his name is Hasita Nipun. I think he will prove theorem. Uh, yeah, they have like these programs, but they don't produce anything, and then the students know it too. Even in the math special, there are they are not committed to math special. So I know that you're in that school, but yeah, do the commit to this thing, and there are a couple of people who are on track to prove a theorem, especially Hasita Nipun, and think I don't know the situation with Dimitri. Uh, yeah, there are some people. I know there's another one, Nalamadu Samar Singh. He's in a good theoretical physics program. So I mean, those are the kids from my first batch when I was in Japura. And yeah, we'll see. We'll see. Any other questions? Any other questions? Questions? Okay, so in this case, let me stop the recording, and let me stop the recording.